Hey everyone, welcome back to the Technology Hub. In this video, we're diving into the world of programming, and I'll walk you through the classic first step in any programming language, the Hello World program. And yes, we're doing it in C++. Alright, let's jump into the code. Here's how a simple Hello World program looks in C++. Don't worry if it looks new. I'll break it down step by step. This line tells the program to include the input-output stream library, also known as IOStream. Think of it as the tool that lets us send output to the screen or take input from the user. Next, we've got this int main part. This is where every C++ program starts. The main function is like the brain of your code. It's where all the action happens. The opening curly brace and closing curly brace define the boundaries of the main function. Everything you want your program to do goes inside these braces. Now comes the fun part. std::cout stands for Standard Console Output. It's like saying, hey computer, print this on the screen. The double less than is an operator that sends the text to the output. And in our case, we're asking it to display Hello World. Finally, the return 0 semicolon line means the program has finished running successfully. It's like the program saying, okay, I'm done, no errors here. Once you've written this code, save it with a .cpp extension, for example, hello.cpp. Then compile it using a C++ compiler like G++. Here's the command. G++ hello.cpp-o hello. And to run it, simply type ./hello. And there you have it. Now comes a simple yet powerful feature, comments. There are two types of comments in C++. First is single-line comment, and the second is multi-line comment. Let's take a look at both. Single-line comments start with $/. Everything after $/. On that line is ignored by the compiler. This is great for adding short explanations or quick notes beside your code. For example, if you're declaring a variable, you can explain its purpose in a single line. Multi-line comments start with / then asterisk and end with asterisk and a /. They're perfect when you need to explain something in more detail, or when you want to temporarily disable a block of code. Multi-line comments are great for documenting sections of code, or leaving notes for complex logic. Just make sure you don't overuse them for things that could be explained in a single line. Alright, let's talk about writing good comments. Just adding comments isn't enough. They need to be clear and meaningful. Here are some best practices. First, focus on the why, not the what. Don't comment something that's already obvious from the code itself. Second, keep them short and relevant. Don't write essays in your code. Be concise. Third, update your comments. If your code changes, make sure your comments still make sense. Stale comments can confuse people more than no comments at all. Fourth, use comments to explain complex logic. If your code solves a tricky problem, explain your thought process so others don't have to reverse engineer it. Fifth, avoid over-commenting. Commenting every single line clutters your code and defeats the purpose. Now let's look at some common mistakes people make with comments and how to avoid them. First, too many comments. Don't do this. The code is already self-explanatory. Second, outdated comments. This is misleading. If you update your code, make sure to update the comments too. Third, commenting instead of refactoring. Instead of commenting this, give the variable a meaningful name. Fourth, overusing multi-line comments for short notes. Don't use multi-line comments for things that could be explained in one line. To sum it up, here are a few situations where comments really shine. Explaining why a decision was made in your code. Documenting complex algorithms or logic. Temporarily disabling blocks of code for debugging. Adding notes to remind yourself of improvements or refactoring later. Just remember, the goal of comments is to make your code easier to read and understand, not harder. Write and run your very first program in C++. Today we're diving into one of the core concepts of programming in C++, data types and variables. You'll learn what they are, why they matter, and how to use them in your programs. Ready? Let's get started. Okay, imagine this. You're trying to write a to-do list, but you don't have anywhere to store your tasks. That's exactly what programming without variables is like. Variables are like storage containers where your program keeps its data. And data types are the labels that say, hey, this container holds numbers, text, or something else. Pretty cool, right? Let's break it down. First, let's talk about variables. A variable is like a box where you store information you want to use later. For example, you can store someone's name, their age, or even the result of a calculation. In C++, you create a variable by telling the program what kind of data it'll hold. That's where data types come in. Now, C++ has several data types, but let's focus on the most common ones. First is int for whole numbers, like 42 or -7. Second, float and double, for decimal numbers like 3.14. Third is char, for single characters like A or Z. Fourth is string, for text like hello world. And the last one is bool, for true-false values. Let's see these in action with an example. Here's how you can declare and use variables in C++. We can declare a variable by defining data type, then variable name. We can also initialize the variable while declaring. To do that, we can start by data type, then variable name, and then assignment operator. This is the operator that is used to assign values in variables. And then the value. Here's a simple program demonstrating how the variables are declared and initialized. Let's break this down. First, we declare variables like int age equals to 25. Here, int is the data type, age is the variable name, and 25 is the value it holds. Then we print them using cout. When you run this, the output will look like this. By the way, 1 for each student means true. In C++, true is stored as 1 and false as 0. Now, before you start creating variables, here are some quick rules for naming them. First, variable names must start with a letter or an underscore. No numbers or special characters at the start. Second, you can't use spaces or C++ keywords like int, return, or if as variable names. Third, make the names meaningful. Instead of calling a variable x, name it age or height so it's easier to understand. Now you might be wondering, why do we need to specify the data type? Well, it's because the computer needs to know how much memory to allocate for your variable and what kind of operations you can do with it. For example, you can't add a number and a string. You can't divide a char by an int. So choosing the right data type is like giving the computer clear instructions. Let's see how variables and data types work together in a small program. In this program, we declare a string variable name and an int variable age. Then we take input from the user using cin and store it in these variables. Finally, we combine them in a message using cout. When you run this, the program interacts with you like. Super interactive, right? Now let's talk about const. In C++, const is short for constant. When you declare something as const, you're telling the compiler, hey, this value or object cannot be changed after it's initialized. Why is this important? Because it helps prevent accidental changes, improves code clarity, and allows the compiler to optimize your program better. Let's start with variables. If you want to make a variable constant, just add the const keyword before its type. The variable myAge is declared as const, which means it cannot be modified after its initial value of 25 is assigned. If you try to change it, the compiler will throw an error. You can also use const with arrays to make the elements unchangeable. And that's the basics of data types and variables in C++. Remember, data types define what kind of data you're working with, and variables are the containers that store it. In today's video, we're diving into operators and expressions in C++, the tools that make your programs actually do something. By the end of this video, you'll know how to add, compare, and even combine data in your programs. Let's get started. So why do operators and expressions matter? Well, think of it like this. Variables are like pieces of data you store, but operators are the tools you use to work with that data. Whether you're calculating someone's salary, checking if they're old enough to vote, or making decisions in your code, you're going to need operators and expressions. Let's break it all down. Let's start with the basics. Operators are symbols that perform operations on data, like plus, minus, multiply, or divide. Expressions are combinations of variables, values, and operators that evaluate to a result. For example, 3 plus 5 is an expression, and its result is 8. Simple, right? Now C++ has several types of operators. Let me show you the most important ones. First is arithmetic operators. These are the ones you probably already know. Plus for addition, minus for subtraction, multiplication sign for multiplication, divide for division, percent sign for modulus remainder of a division. Here's an example. Arithmetic operators are your bread and butter for calculations. Second is relational or comparison operators. These help you compare values. Double equals to checks if two values are equal. Not equals to checks if two values are not equal. Greater than and less than checks if one value is greater or smaller. Greater than or equals to and less than or equals to checks for greater than or equal to and less than or equal to. Here's an example. In the output, 1 means true and 0 means false. This is super useful for writing conditions. Third is logical operators. Now, logical operators help you combine multiple conditions. Double ampersand means and. It says both conditions must be true. Logical or means or. It says at least one condition must be true. Exclamation means not. It reverses the condition. Here's an example. This is great for making decisions, like checking if someone is eligible for something based on multiple criteria. Fourth is assignment operators. Assignment operators assign values to variables. The most common one is equals to, but there are shortcuts. Plus equals to adds and assigns. Minus equals to subtracts and assigns. Multiply equals to multiplies and assigns. Divide equals to divides and assigns. Here's an example. These save you time and make your code cleaner. Now some other operators. Just a quick mention of a few others. Increment and decrement operators. They increase or decrease a variable's value by 1. Ternary operator are shorthand for if-else statements. For example, now let's talk about expressions. An expression is any combination of variables, constants, and operators that evaluates to a value. For example, this is an expression, and the result depends on the values of A, B, and C. Remember, C++ follows the order of operations, also known as precedence. Multiplication and division come before addition and subtraction, just like in math. And that's the basics of operators and expressions in C++. They're the building blocks for making your programs calculate, compare, and make decisions. Today we're talking about control flow, the part of programming that lets you decide what happens, when it happens, and how many times it happens. By the end of this video, you'll master conditional statements, switch cases, and loops. Let's jump right in. Think of control flow as the brain of your program. Without it, your code would just run line by line, with no decisions, no repetition. Basically, no intelligence. Control flow lets you ask questions, make decisions, and repeat tasks, making your program dynamic and interactive. Let's start with the basics: conditional statements. Conditional statements allow your program to make decisions based on certain conditions. In C++, the main ones are if, else if, and else. Here's a basic example. In this program, if your age is less than 18, the program prints you're a teenager. If your age is between 18 and 65, it prints you're an adult. Otherwise, it assumes you're a senior citizen. This is how if, else if, and else work together to handle different scenarios. Sometimes you need to check conditions inside other conditions. This is where nested if statements come in. Let me show you an example. Here, if the grade is 50 or above, the program checks another condition. If the grade is 90 or above, it prints excellent performance. Nested if statements allow you to handle more specific scenarios within broader conditions. Sometimes you want to compare a single variable to multiple values. Instead of writing a bunch of if-else statements, you can use a switch statement. Here's an example. Here's what's happening. The switch statement checks the value of day. Each case corresponds to a specific value, like 1 for Monday or 2 for Tuesday. The break statement prevents the program from executing the next cases. If none of the cases match, the default block runs. This is great when you're working with a fixed set of options, like menu items or days of the week. Loops allow you to repeat tasks without writing the same code over and over again. In C++, you have three main types of loops. First one is for loop. Second is while loop. And the third one is do while loop. Let's go through each one. The for loop is perfect when you know exactly how many times you want to repeat something. Here's an example. Int I equals to 1 initializes the counter. I less than or equal to 5 is the condition. The loop runs while this is true. I++ increments the counter after each iteration. When you run this, it prints. The while loop is useful when you don't know how many times you need to loop but have a condition to check. Here's an example. This loop keeps running until the user enters a number less than or equal to 0. The do while loop is similar to the while loop, but it always runs at least once. Here's an example. Even if the user enters a negative number the first time, the program will still ask them at least once. Finally, let's talk about two special keywords. First one is break. It stops the loop immediately. And the second one is continue. It skips the rest of the loop and jumps to the next iteration. Here's an example using both. When you run this, the output will be, it skips 5 and stops completely at 8. And that's the basics of control flow in C++. We covered conditional statements, switch cases, loops, and even break and continue. These tools are essential for writing dynamic, flexible programs. Today we're diving into arrays and strings. These are fundamental tools for handling collections of data and text in your programs. By the end of this video, you'll know how to declare, use and manipulate arrays, as well as work with strings using both character arrays and the C++ string class. Let's get started. Think about it. What if you wanted to store 100 test scores or process a full sentence in your program? You can't keep declaring individual variables for each piece of data. That's where arrays and strings come in. They help you group and manage data efficiently. Let's start with arrays. An array is like a list of variables of the same type, stored in a single block of memory. You can use arrays to store multiple values of the same type. Let's break it down. To declare an array in C++, you just need to specify the type, the name, and the size. In this example, int numbers declares an array of integers with 5 elements. Each element is accessed using its index, starting from 0. So, numbers at the index 0 is the first element, and numbers at the index 4 is the last. You can also initialize an array right when you declare it, like this. Now let's talk about multidimensional arrays. These are arrays of arrays. They're great for representing grids, tables, or matrices. Here's an example of a two-dimensional array. In this example, matrix is a two-dimensional array with 3 rows and 3 columns. The nested for loops print each element row by row. You can extend this to as many dimensions as you need, though 2D arrays are the most common. Strings are sequences of characters, and in C++ you can handle them in two main ways. First one is using character arrays, and the second one is using the C++ string class. Let's explore both. Character arrays are the more traditional way to work with strings in C++. Here's how you can use them. In this example, charName creates a character array that can hold up to 19 characters, plus the null terminator. When you use cin, it stops reading input when it encounters a space. If you want to include spaces in your input, you can use cin.getLine function like this. You can manipulate character arrays using functions from the C-string library. For example, the string class is a more modern and user-friendly way to work with strings. It's part of the string library and provides lots of helpful functions. Here's an example. In this example, getLine function reads the entire input, including spaces. Name.length function returns the length of the string. You can access individual characters in the string using character index. The string class makes working with text much simpler than using character arrays. And that's a wrap on arrays and strings in C++. We covered how to declare, initialize, and use arrays, including multidimensional arrays, and explored both character arrays and the powerful C++ string class. These are essential tools for handling data and text in your programs. Today we're covering a topic that's absolutely essential for keeping your code clean and conflict-free in C++, namespaces. By the end of this video, you'll know what namespaces are and why they're so useful, how to create and use custom namespaces, how nested namespaces work, and of course, we'll also talk about the std namespace, which powers many of the things we use in every C++ program. If you're ready to take your coding skills to the next level, let's dive in. Imagine you're working on a project with multiple libraries, and both libraries define a function called print. When you try to use print in your program, the compiler gets confused. It's like asking two people named Alex to do the same task. You need a way to tell them apart. Namespaces in C++ solve this problem by acting as containers for your functions, variables, and classes. They help organize your code and prevent name conflicts. A namespace is essentially a labeled box where you can group related code together. If two namespaces have elements with the same name, you can distinguish them using the scope resolution operator. Let's look at a quick example to see namespaces in action. Here, library A and library B both have a print function, but because they're in different namespaces, there's no conflict. You can specify which one to use with library A scope resolution operator or library B scope resolution operator. Tired of typing the namespace name every time? You can simplify things with the using keyword. When you add using namespace, my namespace, the compiler knows to look inside my namespace for any functions or variables. But be careful. If two namespaces have conflicting names, this can create problems. Namespaces can even be nested inside each other, just like folders inside folders. Here's an example. In this case, outer contains another namespace called inner. To call the greet function, you chain them together with outer : inner : greet. In C++ 17 and later, you can simplify the syntax for nested namespaces. Instead of this, you can write this instead. It's cleaner, easier to read, and saves you a few lines of code. Now let's talk about the namespace we use in almost every C++ program. The standard namespace, or std. The std namespace contains all the functions, objects, and classes from the C++ standard library. Things like cout, cin, endl, string. And even mathematical functions like sqrt live inside std. By default, you need to prefix standard library functions with std : like this. But constantly typing std : can get annoying. That's where the using keyword comes in again. By adding using namespace std at the top of your program, you don't need to prefix std : everywhere. While using namespace std is convenient, it's not always a good idea in larger projects. If you're using multiple libraries, there's a chance of name conflicts. For example, this example causes the conflict between custom power function and the one from the std namespace. To avoid issues like this, you can use std : for specific elements instead of importing the entire namespace. And that's namespaces in C++. We covered what namespaces are and why they're useful, how to create custom namespaces and even nested namespaces, how the using keyword works, and of course the std namespace, which powers so much of what we do in C++. Today we're talking about one of the most powerful tools in programming: functions. Functions help you organize your code, make it reusable, and reduce repetition. By the end of this video, you'll understand function declaration, definition, and calling, different return types, including void, how to pass parameters by value or reference, default arguments, and function overloading. Ready to level up your coding skills? Let's dive in. Imagine you're writing a program that needs to calculate the area of a rectangle, a circle, and a triangle. Instead of repeating the same code for each shape, Wouldn't it be great if you could write a function once and call it whenever you need it? Functions are the key to writing clean, efficient, and modular code. A function is like a mini program within your program. It performs a specific task and can be reused multiple times. Functions in C++ have three main parts. The first one is declaration. This tells the compiler about the function. Second one is definition. This contains the actual code for the function. And the last one is calling. This executes the function. Here's an example. Here's what's happening. Int add function with the argument int a, int b declares the function at the top so the compiler knows it exists. The actual function code or definition comes later. When add function is called, it executes the code inside the function and returns the result. The return type specifies the kind of value a function sends back to the caller. In the previous example, int add function returns an integer. But what if you don't want to return anything? That's where void comes in. In this case, the greet function doesn't return a value. It just prints a message. Use void when you don't need to send anything back. By default, C++ passes function arguments by value. This means the function gets a copy of the argument, and any changes made inside the function don't affect the original variable. For example, here, the value of number inside the function changes, but the original variable remains unchanged outside the function. To modify the original variable, you can pass it by reference using the ampersand symbol. Check this out. Here, the ampersand num parameter creates a reference to the original variable, so any changes inside the function affect the original value. Default arguments let you assign a default value to a parameter in case the caller doesn't provide one. Here's an example. In this function, if you call multiply with the argument 5, b defaults to 2. If you provide both arguments, the default is overridden. Default arguments make your functions more flexible and easier to use. Function overloading lets you create multiple functions with the same name but different parameter lists. The compiler determines which function to call based on the arguments. Here's an example. Here, the add function is overloaded. One version handles integers, another handles doubles. When you call add with the argument 5 and 10, it uses the integer version. When you call add with the argument 5.5 and 10.5, it uses the double version. Pretty cool, right? Now let's talk about inline functions and functions with const keyword. Alright, so what's an inline function? Normally, when you call a function in C++, the compiler jumps to the function's code and executes it, then jumps back to the calling code. This is called a function call overhead. Inline functions, on the other hand, tell the compiler, hey, instead of jumping to this function, just replace the function call with the actual function code, right here in the calling code. This eliminates the overhead of the function call and can make your program faster, especially for small, frequently called functions. Declaring an inline function is super easy. Just use the inline keyword before the function definition. Let's look at an example. The inline keyword tells the compiler to replace calls to square functions with the actual code 5 multiplied by 5 and 8 multiplied by 8 during compilation. This avoids the overhead of jumping to and from the function. Inline functions are great, but they're not a magic solution for everything. Here's when they're most useful. First, small, simple functions. Use inline functions for short functions like mathematical operations or simple logic. Second, performance-critical code. If a function is called repeatedly in performance-critical code, making it inline can help reduce execution time. Third, header files. Inline functions are often defined in header files, so they can be used across multiple files without causing linker errors. But like I said, they're not a magic fix. There are times when you should avoid inline functions. First, large or complex functions. If a function is too large, inlining it will bloat your code and increase the size of your executable, which can actually hurt performance. Second, when function changes frequently. If you frequently update the function, you'll have to recompile all the files that use it, since the inline code gets copied everywhere it's called. Third, recursive functions. Inline functions and recursion don't mix well. Most compilers ignore the inline keyword for recursive functions to avoid infinite inlining loops. Here's the thing. The inline keyword is just a suggestion to the compiler. It's not a command. The compiler ultimately decides whether to inline a function or not. Modern compilers are really smart and may choose to inline a function even if you don't explicitly mark it as inline, or ignore the inline keyword if the function is too complex. Let's bring everything together with a practical example. In this example, the multiply function is short, frequently used, and performance critical, making it a perfect candidate for inlining. Next, let's talk about const functions. You can use const in function parameters to ensure they are not modified inside the function. It prevents accidental changes and makes it clear that the parameter is read-only. You can also use const as a return type to ensure the returned value cannot be modified. Here are some best practices to keep in mind. First, use const for variables that should never change. This reduces bugs. Second, use const parameters in functions to make your intentions clear and prevent accidental modifications. Third, use const wherever possible. It makes your code safer and easier to read. And that's everything you need to know about functions in C++. We covered declarations, definitions, calling, return types, parameters, default arguments, and function overloading. Functions are one of the most important tools in programming, so mastering them will take your coding skills to the next level. Today we're tackling one of the most important and powerful concepts in C++, pointers. Pointers can be tricky at first, but once you understand how they work, they unlock a whole new level of control in your programs. In this video, we'll cover the basics of pointers, pointer arithmetic, what null pointer is, dynamic memory allocation with new and delete, and the relationship between pointers and arrays. If you've ever been confused about pointers, stick around. We're going to make them crystal clear. Let's dive in. Alright, so what exactly is a pointer? A pointer is a variable that stores the memory address of another variable. Think of it like a map that tells you where to find data in memory. Here's an example. Int asterisk ptr. This declares a pointer to an integer, ampersand num. The ampersand operator gives us the memory address of the num variable. The asterisk operator dereferences the pointer, letting us access the value stored at that memory address. It's like a signpost pointing to the value stored in memory. Now, let's talk about pointer arithmetic. Pointers are closely tied to memory, so we can perform arithmetic operations like incrementing and decrementing them. Incrementing moves the pointer to the next memory location, which depends on the size of the data type. For example, 4 bytes for an int. Decrementing moves it back. Pointer arithmetic is especially useful when working with arrays, which we'll talk more about later. Now let's say you have a pointer, but you don't want it pointing to any valid memory address yet. That's where null pointer comes in. Null ptr is a special constant that represents a null pointer, meaning it points to nothing. This is safer and more modern than using null or zero in older C++ code. Now let's move on to dynamic memory allocation. This is where pointers really shine. With new and delete, you can allocate and free memory at runtime. New keyword allocates memory on the heap and returns a pointer to it. Delete frees the allocated memory to avoid memory leaks. Notice the use of delete with left and right square bracket when freeing memory for arrays. It's important to use the correct form of delete. Alright, now let's talk about the relationship between pointers and arrays. An array name is actually a pointer to its first element. First, arrays have a fixed size, while pointers can be reassigned to point to different memory locations. Second, arrays don't require delete open bracket close bracket, but dynamically allocated arrays do. And that's a wrap on pointers in C++. Let's quickly recap. Pointers store memory addresses and can be dereferenced to access the value. You can perform arithmetic on pointers to navigate through memory. Null pointer represents a pointer that doesn't point to any valid memory. New and delete allow dynamic memory management. Arrays and pointers are closely related but have key differences. And today we're talking about something super cool and really important in programming: object-oriented programming. Now I know it sounds fancy, but don't worry. Today I'm going to explain it like you're learning your ABCs. So grab your favorite snack, sit back, and let's dive into the magical world of OOP in C++. Okay, let's start with the basics. What exactly is object-oriented programming? Think of it like this. Imagine the real world. Real world is made up of things, right? You have animals, cars, houses, and even yourself. Each of these things has two things. First, properties. These are facts about the thing. For example, a car has a color and a speed. Second, behaviors. These are actions the thing can do. For example, a car can drive or honk. In programming, we can create these things using something called classes and objects. A class is like a blueprint for a thing. Think about it. When you build a house, you first create a blueprint, right? That's exactly what a class is. It describes what the thing is, like its properties, and what it can do, like its behaviors. Now, the object is the actual thing you make from that blueprint. If a class is a recipe, the object is the delicious cake you bake from it. Let me show you an example of a class and object in C++. To access the member of a class, we can use dot operator. Or if the class is created using pointers, we can use arrow operator. We will talk more about arrow operator in upcoming videos. The car class is like a recipe for a car. The myCar object is the actual car. It has properties like color and speed, and a behavior called drive. Alright, so we just talked about classes. Now we need to discuss something important. Access specifiers. Access specifiers decide who gets to see or use the stuff inside your class. They're like the rules for sharing your toys. There are 3 access specifiers. First, public. This means anyone can use it. It's like saying, here's my toy, and you can play with it too. Second, private. This means no one else can touch it. It's my toy, and I won't share it with anyone. Third, protected. This one is special. It's private, but it can be shared with family. Let's imagine you're building a robot. The moment you finish building it, you need to give it some instructions, like its name or what it can do. That's exactly what a constructor does. It sets up an object when it's created. Now what happens when you're done with the robot? You need to clean up the mess, right? A destructor does exactly that. It cleans up when the object is no longer needed. Okay, this is where things get really cool. Inheritance means you can take a class and create a new class from it. It's like saying, if my parent has blue eyes, I'll have blue eyes too. The animal class has a behavior called eat. The dog class inherits it and adds its own behavior, bark. Polymorphism is a big word that just means having multiple forms. It allows one thing to take on different forms. For example, a phone can make calls, take pictures, or play games. It behaves differently depending on the context. We can achieve this in classes by using virtual and override keywords. Encapsulation means bundling data and functions together in one class. It's like putting all your tools in one toolbox. It keeps everything organized. Abstraction. Abstraction means hiding the messy details and showing only what's necessary. It's like driving a car. You don't need to know how the engine works to drive it. Finally, let's talk about friends functions. In C++, a friend function or class can access private and protected members of another class. It's like having a best friend who can open your locked treasure box. And that's the magic of object-oriented programming in C++. We learned classes and objects, constructors and destructors, inheritance, polymorphism, encapsulation and abstraction, friend function and classes. And that's a wrap on object-oriented programming in C++. And today we're going to talk about a superpower in C++, the Standard Template Library, or STL. If you've ever wanted to write programs faster, cleaner, and more efficiently, STL is your best friend. It's like a giant toolbox filled with ready-made tools you can use right away. Here's what we'll cover in this video. First, containers like vector, list, map, and set. Second, iterators and how to loop through containers. Third, powerful algorithms like sorting and searching. By the end of this video, you'll be able to use STL like a pro. Let's dive in. Instead of writing everything from scratch, STL provides you with pre-built tools to save time and effort. Cool, right? Let's start with containers. A container is like a storage box where you can keep your data. STL has many types of containers, but today we'll focus on the most common ones: vector, list, map, and set. A vector is like a dynamic array that grows and shrinks as needed. It's super flexible and easy to use. Use pushback function to add elements. Use popback function to remove the last element. Access elements using an index, just like an array. A list is like a chain. Each element is connected to the next one. It's great when you need to frequently insert or remove elements. Use pushFront function to add elements at the front. Use pushBack function to add elements at the back. A map is like a dictionary. It stores data as key-value pairs. For example, think of a phone book where names are the keys and phone numbers are the values. Keys are unique. Access values using keys like ages, then opening square bracket, then the key name in double quotes, and then the closing square bracket. A set is a container that stores unique elements. It's like a magic box that removes duplicates automatically. All elements are unique. They're stored in sorted order. Next up, let's talk about iterators. Think of iterators as a pointer that helps you navigate through a container. They're like a bookmark in a book. You can use them to visit one element at a time. Finally, let's look at STL's built-in algorithms. These are pre-written functions to do things like sorting and searching. Why should you use STL? It saves time, reduces errors, and makes your code clean and efficient. Imagine building a house. You don't need to make every brick yourself, right? STL is like a pre-built toolkit that lets you focus on the bigger picture. And that's STL in C++ simplified for you. We covered containers like vector, list, map, and set, iterators to loop through containers, algorithms like sorting and searching. Today we're diving into exception handling in C++. Sounds fancy, right? But don't worry. I'll explain it in a way that's so simple even a beginner can nail it. Here's what we'll cover in this video. First, the basics of try, catch, and throw. Second, standard exceptions in C++ and how to use them. By the end of this, you'll know exactly how to handle errors like a pro. So, let's get started. Why do we need exception handling? Imagine this. You're building a program and everything works great until something unexpected happens, like dividing by 0 or trying to open a file that doesn't exist. These are called exceptions, and if you don't handle them, your program will crash. That's where exception handling comes in. It's like a safety net that catches errors and prevents your program from breaking. Let's break it down step by step. Exception handling in C++ revolves around 3 keywords. First, try. This is where you put the code that might cause an error. Second, throw. If something goes wrong, you throw an exception. It's like saying, hey, I found a problem. Third, catch. This is where you handle the problem. It's like saying, don't worry, I've got this. Here's a simple example to show how these work together. The try block contains the risky code, division in this case. The throw statement throws an error message if something goes wrong. The catch block catches the error and handles it gracefully. You're not limited to throwing strings. You can throw numbers, objects, or even custom error messages. Use the data type in the catch block that matches what you're throwing. C++ has a bunch of built-in exceptions in the std except header. These are part of the std exception class, and they make your life easier by providing predefined error types. Here are some common standard exceptions. First, out of range. When you try to access an invalid index in an array or container, Second, invalid argument, when a function receives an invalid argument. Third, runtime error, for general runtime errors. The throw out of range throws a predefined exception when you access an invalid array index. The catch block catches the exception and uses what function to display the error message. Sometimes you might want to handle different types of exceptions in different ways. In that case, you can use multiple catch blocks. The first catch block handles string exceptions. The second catch block handles integer exceptions. If you're not sure what type of exception might be thrown, you can use a catch-all block. It's like a safety net for everything. Before we wrap up, here are some quick tips to keep in mind when using exceptions. First, only use exceptions for errors, not for regular program flow. Second, always provide meaningful error messages. Third, use standard exceptions whenever possible. They're well-tested and reliable. Fourth, avoid overusing catch-all blocks unless absolutely necessary. And that's a wrap on exception handling in C++. Here's what we learned. How to use try, throw, and catch to handle errors. How to work with standard exceptions like std exception. Using multiple catch blocks and catch-all handlers. Today we're diving into something super practical. File handling in C++. Imagine this. You've written a program, but you want to save data for later use or read from a file instead of typing input every time. That's where file handling comes in. In this video, we'll cover how to read from files, how to write to files, using the magic of fstream. By the end of this video, you'll be confidently working with files in C++. Let's get into it. What is file handling? File handling is all about reading data from a file or saving data into a file. Think of it as a way to make your program remember stuff. C++ provides the fstream library for file handling, and it has three main classes. ifstream, for reading files. ofstream, for writing files. fstream, for both reading and writing files. You'll need to include fstream header file in your program to use these. Let's see how it works. Let's start by saving data into a file. This is where ofstream comes in. Think of it like opening a notebook to write something down. We use ofstream to create or open a file for writing. Out file insertion operator, then some text. This writes data to the file. And don't forget to close the file with close function when you're done. Next, let's read data from a file. This is where ifstream comes in. Think of it like opening a book to read. We use ifstream to open the file for reading. Then the getLine function reads the file line by line. And lastly, close the file with close function when done. Sometimes you want to read and write to the same file. That's where fstream comes in. It's like having a pen that lets you write and erase at the same time. The ios : or ios scope resolution operator and then in flag opens the file for reading. The ios scope resolution operator and then out flag opens it for writing. And the last, the ios scope resolution operator and then app flag appends data to the file without overwriting it. Before we wrap up, let's talk about some common issues you might face. First, file not opening. Always check if the file is open using is open function. Second, data corruption. Be careful with modes like iOS trunk, which overwrite existing files. File handling is everywhere. Whether you're working on saving user data, logs, or even creating text-based games, file handling is a must-have skill. Once you master this, the possibilities are endless. And that's file handling in C++ for you. Here's a quick recap of what we covered. How to write to files using ofstream. How to read from files using ifstream. Using fstream for both reading and writing. Today we're going to use some powerful features from modern C++. Features introduced in C++ 11, C++ 14, C++ 17, and C++ 20. Here's what we'll cover. First, Smart pointers like unique pointer and shared pointer. Second, Lambda functions for quick and concise coding. Third, move semantics and R-value references for efficient memory use. Fourth, cool keywords like auto, const expr, and decal type. Fifth, the versatile range-based for loops. Let's dive right in. Smart pointers make memory management a breeze. Instead of manually calling delete, smart pointers automatically free up memory when no longer needed. Let's look at the two most popular ones: unique pointer and shared pointer. A unique pointer owns a resource exclusively, meaning only one pointer can manage the resource. A shared pointer allows multiple pointers to share ownership of the same resource. It keeps track of how many references exist and deletes the resource when the last pointer is destroyed. Lambdas are inline, anonymous functions that make your code cleaner. Instead of writing a full function, you can define a lambda function right where you need it. Want to use a variable outside the lambda? Capture it. Move semantics transfer ownership of resources instead of copying them, improving performance for large objects. Let's simplify how we define variables and values with these modern keywords. Auto keyword, it means automatic type deduction. Let the compiler figure out the type for you. Const expr keyword. Const expr ensures a value is computed at compile time. Decal type keyword. Want to know the type of a variable or expression? Use decal type. Range-based loops make working with arrays and containers a breeze. No more worrying about indices. Want to change the values? Use references. Now let's talk about why these modern features matter. Modern C++ features are all about making your code cleaner, safer, and more efficient. They simplify complex tasks, optimize performance, and reduce the risk of bugs. Once you start using them, you'll wonder how you ever coded without them. And there you have it, modern C++ features. Here's what we've learned in this video. First, smart pointers for memory management. Second, lambda functions for compact coding. Third, move semantics to transfer resources. Fourth, keywords like auto, const expr, and decal type to simplify type handling. Fifth, the game-changing range-based for loops. Today we're diving into the world of multithreading and concurrency in C++, one of the coolest ways to make your programs run faster and do more things at the same time. Today we will be looking at threads using std_thread, synchronization tools like mutexes, and locks to avoid those tricky bugs. Ready? Let's jump in. First up, let's talk about threads. A thread is like a separate path of execution in your program. Imagine you're baking cookies and vacuuming at the same time. That's multitasking, just like multithreading in programming. In C++, we use std_thread from the thread library to create and run threads. You can pass arguments to a thread function like this. Want to skip defining a separate function? Use a lambda function. Threads are great, but what happens when multiple threads try to modify the same resource at the same time? That's where synchronization comes in, ensuring things don't go haywire. A mutex, short for mutual exclusion, allows only one thread to access a resource at a time. Instead of manually locking and unlocking a mutex, you can use std_lockguard or std_unique_lock to handle it automatically. Without synchronization, you could end up with a race condition, where two threads modify a resource at the same time, leading to unpredictable results. Mutexes and locks help ensure your program behaves as expected. Here are a few quick tips to keep in mind. First, keep your critical sections small. Only lock what's necessary to minimize bottlenecks. Second, use std_lockguard or std_unique_lock to make mutex management safer and easier. Third, avoid deadlocks. That's when two threads are waiting on each other indefinitely. Be careful with the order of locks. Fourth, use std_thread Join to ensure your threads complete before your program exits. Once you get the hang of these, you'll be able to write faster and more efficient programs. And that's it. We've covered the basics of multithreading and concurrency in C++. Today we learned how to define and use threads with stdthread, how to synchronize threads with mutexes and locks. Today we're talking about templates and metaprogramming in C++. These are the tools that let you write more flexible, reusable, and efficient code. Templates might sound intimidating at first, but trust me, once you learn how to define and use them, they'll make your coding life so much easier. Here's what we'll cover. Function templates, class templates, template specialization. Sound exciting? Let's dive in. Let's start with function templates. Imagine writing a function for adding 2 integers, another for adding 2 doubles, and yet another for strings. That's a lot of repetitive code, right? Function templates solve this problem by allowing you to write one generic function that works with any type. We can define a template by using the template keyword and then type name t. Here t is the data type that will be used when the function is called. See how that one template function works for integers, doubles, and even strings. That's the power of templates. Next up, class templates. Just like function templates, class templates allow you to design a single class that works with multiple data types. Here, we've created a single box class that works with both integers and strings. Imagine how much code this saves compared to writing separate classes. Sometimes you'll want a template to behave differently for a specific data type. That's where template specialization comes in. It lets you customize the implementation of a template for a particular type. Here, the box class behaves normally for most types, but it gets a special implementation for string types. Neat, right? Why templates and metaprogramming are game changers. Templates are the backbone of reusable code in C++. Libraries like the standard template library heavily rely on them, making containers like vector, map, and set possible. With metaprogramming, you can even do compile time calculations and optimizations. Templates truly make C++ both powerful and flexible. Before we wrap up, here are some quick tips for working with templates. First, keep your templates simple. Don't overcomplicate things. Focus on reusability. Second, use template specialization sparingly, only when you truly need it. Third, leverage STL. The STL is built on templates, so it's a great place to learn and apply these concepts. Templates might feel a bit tricky at first, but the effort pays off once you see how much more powerful and elegant your code becomes. And that's a wrap on templates and metaprogramming in C++. Today we learned how to define and use function templates for flexible functions, how to create class templates for generic classes, how to customize templates with template specialization. If you enjoyed this video, don't forget to like, subscribe to Technology Hub, and let me know in the comments how you'll use templates in your projects. Until next time, happy coding.